Dear colleagues, we are pleased to take part in the International Conference of Infrastructure Construction, Materials, Structures and Technologies. Let me present a report, Energy and Economic Efficiency of Automation of Work on the installation of enclosing structures made of masonry. The need for low-rise industrial and civil buildings made of masonry is increasing every year. The speed and quality of masonry work, as well as construction safety, can be increased by using construction robots for bricklaying. The purpose of study is to develop recommendations for choosing a method for constructing masonry. During the study, a thermal engineering calculation of enclosing wall structures made manually and automatically was performed, and the timing and cost of the work were calculated. When you're choosing a brand of construction robot mason, you need to take into account the following criteria: manufacturer, cost of the robot, speed of work, functionality, reach radius of the boom, and etc. As part of the study, we will compare the characteristics and functionality of several brands of construction mason robots. The main characteristics of the selected robots are presented in Table 1. Based on Table 1, we choose the KUKA robot made in Germany. Its price is more affordable than other robot options and its speed is faster. The KUKA robot can place almost 620 bricks per hour. It's multifunctional and its range of action is 2.89 meters. We will use the characteristics of this selected robot for further calculations. Thermal technical calculations of masonry will be carried out for wall structures of 1.5, 2 and 2.5 bricks, made manually and mechanized. The normalized volume of the reduced resistance to heat transfer of the enclosing structures was calculated and equal to 2.99. Thermal characteristics of the enclosing wall structure made manually are presented in Table 2. The thermal characteristics of the enclosing wall structures made of 2.5 bricks using a robot method are presented in Table 3. The results of thermal engineering calculations for manual and robotics methods of work for 3 types of masonry are summarized in Table 4. We will calculate the timing and cost of masonry installation work for manual and robotics methods, using the example of a standard series of residential buildings located in St. Petersburg. The required quantity, price and total cost of materials required for masonry construction are presented in Table 5. The cost of work on the installation of brickwork for the enclosing wall structures of the buildings with masonry thickness of 2.5 bricks, performed manually and mechanized, is presented in Table 6. If you compare the turnaround time, the KUKA robot completes masonry work much faster than the manual method. If we multiply the cost of manual construction of one floor by the number of floors, we get the cost of manual construction exceeds the cost of purchasing a cooker robot. Let's move on to the results of our research. First of all, the lowest value of the conditional resistance to heat transfer of enclosing wall structures is found in structures made of brickwork on cement sand mortar, which has a high thermal conductivity coefficient, which reduced the thermal performance of the entire enclosing wall structure. Replacing cement sand mortar with materials with a lower thermal conductivity coefficient will increase the heat transfer resistance of enclosing wall structures. Wall structures made of adhesive-based brickwork showed the best results in terms of thermal characteristics. Depending on the thickness of the adhesive base, the conditional heat transfer resistance can be on 2.6% higher. Polymer thermoblock construction adhesive can be recommended for use in all types of masonry, since it has been tested and complies with regulatory documents and has also shown good thermal and functional characteristics. Taking into account the cost of purchasing robotics equipment, the cost of construction and standard floor of a standard series residential buildings using an automated method is 8 times greater than using manual labor. Therefore, the use of robot masons is advisable for large volumes of work. The use of robot masons is possible mainly in low-rise construction, since a machine the size of a truck is difficult to use in high-rise construction. To solve this problem, you can use smaller robotic manipulators, which, however, have low productivity. Thus, taking into account the cost of robotic masons and the lack of offers for leasing and rental of this equipment, today the use of robotic equipment on individual construction sites is not economically feasible. However, taking into account emerging domestic developments and an increase in the volume of housing being built, the use of robot masons may become economically justified in the coming years.